everybody, Mr. D here, checking in from Math Muscle. This is a SL Paper 2 question from May 2014 exams, Time Zone 1. We're given a bunch of information here. It's an interesting layout. Let's just have a look. We're given that the function f at x is a quotient, another function gx divided by hx, where the value of g at x equals 2 is 18, the value of the function h at 2 is 6, the first derivative of g at 2 is 5, and the first derivative of h at 2 is 2. Find the equation of the normal to the graph of f at x equals 2. So anytime we're talking equations, you may remember from prior learning, there are two requirements for equation of a line. Let's try that again. When we're trying to find the equation of a line, regardless if it's a normal or not, we need the slope of a line and 1 point on the line. So plus 1 point on the line. And it can be given in a variety of formats. So let's just see what we can do. The slope of a line plus 1 point on the line. Well, we know that x equals 2, so we have a partial point. We have the x coordinate of f. So if we can sub in x equals 2 here, and if we know what g at 2 is, which is 18, and if we knew what h at 2 is, which is 6, then we divide the 2 and we come up with the y coordinate, so we can find the point on the line. To find the slope, that's a rate of change. Calculus specializes in finding rates of change by virtue of the derivative. So we're going to have to do the derivative of the function f. And because it's a quotient, we may need our formula booklet for the quotient rule. So let's have a look, shall we? First, we're going to require the slope at x equals 2. So in other words, what we meant to say here is the slope, which is f prime at x. But in our case, x is actually equal to 2. So first, let's find the derivative. And then we'll find 1 point on the line. Quotient rule from our formula booklet, as stated here, formula booklet. The value of the first derivative at 2 is equal to the first derivative of the numerator at 2 times the denominator as it is at 2 minus the derivative of the denominator at 2, which is 2, times the value of the denominator, or the value of the numerator at 2, which is 18. So derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, again provided by your formula booklet, at the value of 2 in each of those cases, divided by the value of the denominator at x equals 2 squared. So that would be 6 squared. Do a little simplification. Again, it's paper 2. If you enter it carefully, you do the numerator first in your graphing display calculator, and you come up with, you come up with 30 minus 36 over 36, which is negative 6 over 36, which is negative 636, or negative 1/6. But that would be the slope of the tangent line. But we want the normal. In other words, we want the equation of the line perpendicular to that. And you may remember that the negative reciprocal of a given slope, so in other words, if we know the slope is negative 1/6 of the tangent, we do the negative reciprocal. So you take the opposite sign and you switch the numerator and denominator, and then you get 6. So now we have the slope that we need, is 6. We need the point on the line. Well, we know x equals 2, so we have to sub in f at 2. And that's basically what I've indicated there. So we're given x is 2. Now we need the y coordinate, which is the value of the function at 2. The function is g at 2 divided by h at 2. 18 divided by 6, and there you have it. So now moving along, the normal's equation is in the form y equals mx plus b. We do not have the b value, the y-intercept, so we're going to sub in our m is 6, our x is 2, our y is 3, and doing some housekeeping, we get negative 9 equals b. So y equals 6x minus 9 is the equation of the normal. I hope that helps. If you have any questions or comments, or if you simply like to like the video, please click down below and add your comment as you see fit.